Hello and welcome to the Argos Advanced Training. My name is Jessie and I'll be leading the training today. The intended audience for this training is the Argos DataBlock Designer and the Argos Administrator. The prerequisites for this training are the Report Viewer, the Report Writer, and the DataBlock Designer. The goal is to demonstrate advanced techniques such as creating multiple forms and drill-down charts, creating OLAP cubes, setting up API calls, and creating a schedule that does bursting. We will be covering the following objectives in this training: an overview of the DataBlock Designer and Argos Administrator, how to add more forms to the dashboard and how these forms can be used to create drill-down charts, how to add and configure an OLAP cube, set up an API report, and set up a schedule to burst the output. All of the objectives we're going to be covering today in this training only apply to DataBlock Designers and Argos Administrators. However, there is a difference between the two roles. This table shows the difference between the two user roles. Notice that the Argos Administrator has access to more operations than the DataBlock Designer. The purpose of a DataBlock Designer is to create data blocks, as opposed to an Argos Administrator, who has the ability to do the same operations as a DataBlock Designer, in addition to editing APIs and accessing the trash bins. If you would like to see all of the operations available for each user role, please see the in-product help. The first two topics I'd like to cover are multiple forms and charts. Depending on the amount of objects that you need in your form, or the setup you're trying to accomplish, one form may not be enough. Argos allows you to use multiple forms within one data block. In our example, you'll see how separate form can be used to display the results in a chart. We'll also take a look at how to create new forms and how to display results in a chart. And we'll take a look at how to create new forms and how they can be accessed. We'll also take a look at how to create a chart and how charts and forms can be used together to create a drill-down chart. Today we will be working with the address information data block, the same data block that you've seen in previous trainings. To add a new form to our data block, we simply click on the plus sign at the top left of the Forms tab. Let's give this new form a more meaningful name, such as what the form will contain. Since this form will contain a chart of a student's gender, we'll name it Gender Chart. We have now created our additional form. So that all of our forms will have a similar look, I have saved a template with my background image, logo, and DataBlock title into the library of objects. I can now retrieve it from the library and save myself some time. Now that the base of our form is complete, we'll need a way to access this form from our main form. There are two ways a form can be accessed from another form: using a tab or via a non-click event. Let's take a look at the tab method first. To create a tab form, simply highlight the form on the Forms tab and then go to the Properties tab. Let's change Is Tab to Yes and the tab name to Gender. Now we'll make the main form a tab also, so that we can go back and forth between the two forms. So we'll go to the Properties and change Is Tab to Yes. And now let's commit and test to see how the tabs turned out. Notice that we now have two tabs in the upper left-hand corner of the screen. The tabs contain the form names. Clicking on the tab will activate the form. The second method of accessing a form is with the use of an object's on-click events. For this example, we will use labels to create a navigation menu. Clicking on the label will activate the associated form, similar to how tabs worked. We'll start by adding a label to our gender chart form. And we'll configure the label. And we'll use this label to take us back to our main form. So I'll change the text property to main. Next, we'll configure the onClick property by clicking on the ellipses in the onClick property. Select Activate Form from the list of available events and move it over to the events list by clicking on the plus sign. In the form name dropdown, we'll select the main form. And we'll want a way to let users know that you can click on this label, so we'll change the cursor property to handpoint. And now, as you can see, the cursor turns into a handpoint when hovering over the main label, letting users know that you can click on it. And now that we have a way to go back to our main form, let's create another label that tells us what form we're on. We'll go ahead and copy and paste this main label. And we'll rename this new label Gender Chart. And then we'll use the alignment tools to align the labels. And for this label, we're going to set the cursor back to the default. Remove the onClick event. And so that users will know what form they're on, we'll go ahead and change this label to be bold. We have now created a navigation menu on our form, so we're now able to get back to our main form by clicking on the main label we created. To get from our main form back to our gender chart form, we'll have to create a similar navigation menu. Since we have already created these navigation labels on this form, we'll just go ahead and copy and paste them over to our main form and modify their properties. For the main label, we'll change the cursor back to default. Make the text bold. And remove the onClick event. For gender chart, we'll change the cursor to handpoint. Remove the bold. And add an onClick event. So we will activate the form of gender chart. Now let's commit and test to see how everything worked out. Okay, and here we can navigate our gender chart form in two ways. We can click on the gender chart label or click on the gender tab up at the top. We can also navigate to our main form by clicking on the main label or clicking on the main tab up here. Now that we have our gender chart form ready to go, we'll need to add a chart object to it. Click on the pie chart icon to select the chart object, then place it on the form. You can either draw a box with the chart icon selected to make it smaller or larger, or you can use the handles to resize it. We'll want to make sure that the chart stretches all the way to the borders of the form, so it's easy to read and view. Next, we'll change the variable name property of the chart to something more meaningful. Since this chart will show the gender information, we'll rename it parm CHT gender. Because the graph we are creating will use a different data set than our report query, we'll have to create a SQL variable to return the data. From the Design window, click on the Variables tab, and then click on the plus sign to add a variable to the list. We'll use a SQL statement, so we'll leave the SQL statement radio button selected. We could select the rule and pencil icon to go into the Visual Designer. But the SQL statement is easy enough that we'll just go ahead and copy it and paste it into the SQL editor box. For this chart, the query will count the number of males and females from the table. We'll also use a decode function to set the value of M as male and F as female. Anything other than M or F will be counted as unknown. Now that we have our query, it will have to be validated before it can be used. Let's click on OK and Yes to validate. Let's give the SQL variable a more meaningful name, such as gender count. And now we can begin to set up our chart. From the gender chart form, double-click on the chart object to bring up the chart wizard. Please note that Argos Web Viewer allows users to view charts on mobile and non-Windows devices. However, its starting library is a streamlined version of the Argos charts, which does not support all the features offered in the chart wizard. For more information, click on the More Information link here. For now, let's go ahead and close out of this window and click on Next to go to the Series Manager. The Series Manager is what allows us to create and manage a series using a chart. A series is basically a set of values that are grouped together for the purpose of displaying them in a meaningful way. The Series section displays the available series, as well as its chart type and the associated data set. The Series section displays the available series. The Data tab is where you select and name the series, assign or create a data set, and specify what field will be used as the value and what will be used as the label. The Type tab allows you to select which chart type to use. The default type is a bar chart, but other charts such as pie, gauge, line, points, and area charts are also available. The Labels tab is where you can configure the label properties. Here you can configure whether or not a label will be visible, will be surrounded by a frame, and what font, color, and size the text will be. We'll begin by clicking on the plus symbol to add a new series. And note that a new tab called Bar Options was created when I added the new series. Depending on what chart type you use, there are additional options for displaying the chart. Here we can see that we have the option to display the bars horizontally and specify the bar color. Back in the Data tab, we'll name the series Gender Series. And let's select Gender Count from the Dataset drop-down menu. This is a SQL variable we created previously. We'll use count as a value and gender as a label. In the Types tab, we can select the chart type we would like to use. Let's use a pie chart for this example. On the Labels tab, we'll verify the labels are set to visible and make the frames transparent. And on the pie options, we'll verify the circled option is checked, and then check the 3D option to give our chart a 3D look. Click on Next. This is the Chart Theme and Panel window. Here we can apply a theme and palette to our chart. We can also format the background panel. Let's use a business theme to give our chart a gray background and the opera palette for the color of our pie sections. We'll leave the Format Background panel as is and click on Next. The Chart Legend and Titles window allows us to configure where and how the legend and titles are displayed. Let's make the main title of this chart Gender Count in the Titles tab. And let's change the font to 18. We can now commit and test to see how our chart will look like. From here, we'll click on the Gender tab to get to our gender chart form. And you will see the pie chart we just created along with our count being displayed as our chart value and gender as the labels. We have now learned how to create multiple forms and how to create charts. Next, we'll take a look at how these two features can be combined to create a drill-down effect. We will be expanding the functionality of the pie chart we just created so that when you click on the slice of the pie, a breakdown of the count will be displayed. For this example, we'll break the gender count by ethnicity. We'll need another SQL variable to create our ethnicity chart. We'll create this new label using the same method as before. So let's go ahead and add the new SQL variable. Just like earlier, we will be using free type rather than the Visual Design Editor. For this query, we're going to get a breakdown of the student count by ethnicity based on the gender selected in the pie chart. Let's go ahead and click on OK. Then Yes to validate. We don't need to enter anything in the parameter value, so we'll go ahead and just click on OK to validate. And now we'll go ahead and give the SQL variable a more meaningful name, such as ethnicity count. And now we need to add another form to our data block to hold our second graph. We'll name this form Ethnicity Drill Down. If you recall in the beginning of the training, we added a form template from the library of objects to our gender chart form. We'll do the same thing here to get the same look and feel. Now we'll copy and paste the labels from the main and gender chart form to our ethnicity form, as well as add a new label for our new form. We'll change the text to ethnicity drill down. And now we're going to reconfigure all the properties. The main label will stay as is, and the gender form label will be modified. We're going to change the cursor to hand point. Remove the bold, and add an on-click event to activate the form of gender chart. The ethnicity label will stay as is. And now we're going to create a new chart in the same way we did our first chart. We'll name the variable for this chart param CHT ethnicity. And again, we'll double-click on the chart to open up the chart wizard. Close out of the pop-up message and click on Next. And now that we're in the Series Manager, let's click on the plus symbol to add a new series. And let's name the series Ethnicity Series. And select Ethnicity Count from the Dataset drop-down menu. We will use Count for the value and Ethnicity for the label. This time we'll display the information using a bar chart. And to keep a consistent look and feel, we will configure this chart like we did our previous chart. On the Labels tab, we'll verify the labels are set to visible, and we'll make the frame transparent. Let's go ahead and click on Next. And again, we'll use the business theme to give our chart a gray background and the Opera palette for the color of our bars. And we'll click Next. Let's make the main title of this chart Ethnicity Breakdown. And again, the font will be 18. And let's click on Finish to complete our chart. Now we need to give the gender chart a non-click event. We'll do this the same way we did for our navigation labels. Let's go to our gender chart form by selecting it from the Forms tab. And click on the chart object so we can configure the properties. Click on the ellipses next to the on-click property. Here we have the event editor. And we want to configure the on-click event so that when the section of the pie chart is clicked, the ethnicity breakdown for that section is displayed. To do this, we'll add Activate Form to the event list. And then select the ethnicity drill down from the form name drop-down. Now let's commit and test to see how everything looks like. Let's go to the gender form, click on Male, and you will see the ethnicity breakdown for the males. If we go back and click on Female, we'll get the ethnicity breakdown for the females. And the same thing if we click on Unknown. And if we go back into the gender chart, the on-click event will happen if you click anywhere within the chart, but it is specific to which wedge you click on. So when we click on the blue wedge for Unknown, we will get the information for Unknown. Okay, and I did see someone ask to view the SQL, so let's go back to that. So if we take a look here, we are getting the ethnicity and the count, and we're using the code to give us male, female, and unknown, and we are narrowing this down by the gender selected. This here would be the wedge that is chosen within that chart. And next, we're going to go over OLAP data cubes. OLAP, or Online Analytical Processing, is a specific way to represent statistical data for executives, specialists, and analysts. It is designed to aid in the decision-making and better information understanding. A popular definition is a million spreadsheets in a box. The key to an OLAP cube is its ability to let the end user configure different views of the same data. An OLAP system allows users to get into details or generalize, filter, sort, and regroup the data at the time of analysis. The user is presented data in an electronic spreadsheet format. By moving rows and columns or clicking on them, the user makes the system perform calculations and show different data in different aspects. Back in Argos, we'll start by creating a new form in our address information data block. We'll name this new form OLAP. And we'll set it up just like the gender chart forms, using the tab property to allow us to access the form. So we'll change is tab to yes, and the tab name to OLAP. And we'll also use the same form template as before. And next, we'll create the OLAP cube. Click on the cube icon to create the OLAP cube on the form. By holding down the mouse while forming a square. You will now see a blank OLAP cube on the dashboard. Double-click on it to open up the OLAP cube wizard. The first window of the Build OLAP Data Cube wizard is where you will set the main properties of your cube. Use the pane on the left-hand side of the wizard to select General, Totals, or Subtotals to configure them. Under the General section, we have the following options. Supersaturated. This is used for advanced calculation. However, please note that enabling this option will require more memory. Exclude zeros from the average. This will eliminate entries that are zero from any average calculations. You can hide empty rows and columns, and show dimension and measure toolbars, and auto-expand all rows and columns. Please note that these options will also require additional resources. When enabling one of these options, it will prompt a warning message. For example, if we enable the auto-expand all rows, it will warn us enabling this feature may consume large amounts of resources. For more information about these general options, please view our in-product help by pressing the F1 key. The Total section allows you to select the location of both the row and column totals. Selecting None will hide the totals. The Subtotal section allows you to choose whether or not to show subtotals and select their positioning. For this OLAP cube, I'll go ahead and keep the default settings and click on Next. Here's where we will build our query. OLAP cubes are populated by one or more datasets. If your data is arranged in a true star schema, you can simply create the fact and dimension table queries and link them when you configure the dimensions. If your data is not arranged in a star schema, it is typically best to create a single query that contains all your measures and dimensions. For this example, we're only going to use a fact table. However, if you want to add more datasets to the OLAP queue, you can click on the plus sign on the bottom left. And with the new dataset, you can rename the dataset by clicking on the pencil icon. And you can delete it by clicking on the X icon. Please note that you cannot rename or delete the fact table. For the fact table, I'm not actually going to go to the Visual Designer to build the query. Instead, I have a query that I will copy and paste. And in this example, we're going to be displaying the same information as we did on the charts we created earlier. We have the number of males and females and the ethnicity count. So we're going to get the information from the three tables provided in, as to the first and as to the ethnicity. Let's go ahead and click on Next. In this window is to configure the measures. The measures are numeric items that you want to count, sum, average, or perform other calculations on. So the screen allows you to pick the fields from the fact table you want to measure, configure the measure options, such as display, calculation method, and format, and create calculated measures which are derived from one or more fields from the fact table. You can create a calculated measure by clicking on the calculator icon. And here you can create your own calculated measure. To add a new measure, click on the Add a New Measure button, and we'll name this new measure. Notice that when we create the new measure, a calculated formula will populate the baseline script where you can write your own calculated measure. On the bottom, there is a list of available measures, which is a list of measures that are available in this OLAP data cube based on how the cube was created. And on the right, we have available views, which lists the different types of views or calculations that are available in the calculated formula. This is a sample script that can be viewed by clicking on the in product held by pressing the F1 key. And once you get to this page, you will see an example of a calculation that you can use for your reference. Now let's go ahead and add our measures. For this example, I only want to measure the gender. This can be done by either dragging or dropping the fields in the available fields to the measures box, or by double-clicking on the field. And I'm going to change the display name to make it easier for my users to read. Let's change this to gender. And here we can change our calculation method. I'm going to change this calculation to count. This will count the number of males and females. And I'm also going to change the display format. Right now, it shows two significant figures after the decimal point. I want to remove the decimal point, so I'm going to remove the 0.00 so that it just reads 0. And we also have a distinct option to make sure that duplicates will only be counted once. We'll go ahead and leave it unchecked for now and click on Next. This is the Configure Dimensions area, where you can control how your measures will be grouped. There are 3 tabs, which are the initial locations for dimensions. Dimensions in the Available tab are dimensions that are available for use with the report writer, but are not used as row or column dimensions at the start of the cube. Available dimensions can be dragged and dropped into the column or row of the cube during the runtime to manipulate the cube. Dimensions placed in the Column tab will be default column dimensions in the cube, and dimensions placed in the Row tab will be default row dimensions in the cube. To add the fields to the tabs, you can double-click on the field, or you can click and drag the dimensions onto the tab. I'm going to go ahead and add gender into column, and description and PIDM onto row. And then I'll go ahead and change the display name for each. And you can see that the display names have been changed in the preview of the OLAP cube on the right-hand side. In the middle, notice that we have additional options. We have 2 options for the data from this dimension comes from, and they are directly from the fact table. The field for this dimension comes from one of the selected fields in the fact table, or from another data set. The field for this dimension comes from one of the data sets in addition to the fact table. We also have sorting options and forecasting, which allows you to apply various forecasting methods to your data and compute future trends. Please note that most of the forecasting methods require at least 3 data points. I'm going to leave these settings as default and click on Next. The last window of the OLAP Cube wizard is where you can choose a style. Select the style from the Library of Objects Explorer on the left. These styles we're creating using the Library of Objects Manager from the main Argos interface. If you change the color theme property for the OLAP cube, it will override and remove the applied theme. I'm going to use the eVision 11 standard style for the OLAP. And then we'll click on Finish. And now that we're done with our OLAP cube setup, let's commit and run a dashboard to see the changes to the data block. Here's the OLAP cube, and you can see the different ethnicity and count based on the gender. Also notice that the description is on top and the PIDM is on the bottom. This means that we can drill down the ethnicity so we can see the PIDMs that are part of the ethnicity group. So now when we expand the ethnicity column, you will see that it's showing only the PIDMs and the count. It's difficult to determine who falls into the ethnicity based on the PIDMs. It would be easier if we can see the actual names instead. Also, some of the PIDMs have zeros across the gender. This means that this person is not part of this ethnicity, and it is a waste of space for the users to see. We can make additional changes so that we see the names and exclude them if they do not belong to ethnicity group. And here we have the PIDMs because that is one of the groupings you wanted to include. But since it might be easier to see the names, we're going to go ahead and go through an example of how to do this. And to exclude zeros from the OLAP cube, we can hide these values by enabling the Hide Empty Rows and Columns. And so if we want to change the pitums to be the actual names instead, there are two ways we can do this. Rewrite the query in the fact table to include the names, or create an additional dataset that pulls in the names. For this example, we will create a new dataset. To add the dataset, click on the plus sign, and let's rename this to name. I'm going to pull the pitum and concatenate the first and last name from the spread table. And again, I'm going to copy and paste my query into the SQL window. And next, we need to get to the dimensions and change the spread and pitum so that I will show the names. So let's go to the Rows tab, select the pitum, and now we're going to change the datasets from this dimension come from to from another dataset. And notice that additional options appear when the from another dataset option is selected. The dataset contains all of the datasets that were created in the OLAP cube. The key field is used to specify what field in the selected dataset links the fact table to the selected dimension. The data field specifies what field in the selected dataset will be displayed when the queue is run. And the parent field is used to specify what field in the selected data is considered the parent of the data field. The value can be left blank if there is not a hierarchical value set. For this dataset, we'll select name, which is the dataset we have created in our previous screen. For the key field, we will use spread and pitum, and we'll change the data field to the concatenated names. Let's click on Finish and commit the changes. Let's go ahead and run the dashboard. And we'll go back to the OLAP form and expand a group. And notice that now we have the names instead of the pitums, and we no longer see any names with zeros across the gender. There are two additional options that we have for OLAP cubes: saved OLAP settings and saved states. Saved settings allow users to save the current settings of an OLAP cube. The saved settings include items such as the current dimensions, measures, filtering, and any custom formatting such as column widths, so we can quickly return to the same cube view we had previously. Saved states allow you to save the data as it was at the time the report was run, so that it can be reproduced exactly as it was at the time. When you run the report, you will be prompted to select which saved state you would like to use. To create a saved state, you must create a schedule. First, we'll go over how to utilize the saved OLAP settings. To use the saved OLAP settings, first I'm going to move the dimensions. And now I'm going to expand the gender. And if I want to keep these settings, I have to right-click on the OLAP cube, go to Saved OLAP Settings, and Save Current OLAP Settings. The Create New Saved Settings window will appear. Here's where you can create a new saved setting or overwrite an existing one. Type in the name of the saved setting and a description if you'd like. Now let's see how this works. I'm going to close out of the dashboard and run it again. And notice how nothing expanded and the dimensions are back in their default locations. Now I'm going to load my saved setting by right-clicking anywhere on the OLAP cube, hovering over Saved OLAP Settings, and clicking on the name of the saved setting we created earlier, Example Saved Setting. Now you will see that the saved settings have been loaded. Next, I'm going to go over save states. Remember, the save states have to be created through a schedule. To create a schedule, highlight the dashboard and select Schedule. First, let's deactivate the schedule, and then click on the Task tab. Select Save and Execution State and click on Add. This will add the saved execution state to the Added Task section. When we added the Save State Execution task to Added Task section, the Edit Saved State Task window appears. I will keep the default values and click on OK. And now to test the schedule, click on the Test button and click on Yes to continue. The schedule should finish almost instantly. And to view the saved state, we have to run the dashboard. If it was done correctly, you will be prompted to select a saved execution state. Notice that the Choose a Saved Run State window will appear. You can select to either run the dashboard live, load a saved state from a file, or select a saved state to run. You also have the ability to save a saved state to your file system. And if we go back into the OLAP cube, if we click on Run Live, we have the option to run it live. And if we also cancel, we will be closed out of the window. Okay, our next topic is the Argos API. This is an optional module that enables the user to call Argos reports and their schedules outside of the Argos software. Since the API can make the data available to a wide audience via the web server, portal, or third-party application, only an Argos administrator can enable a report to be available via the API. An API-enabled report or schedule can be executed through 3 different methods. One method is the HTTP GET request, which is much like the standard URL web page link. Another method of executing the report is via POST form, in which a calling web page gathers any needed parameters. Lastly, there is the interactive method. The interactive mode allows you to call Argos reports from portals, web pages, or third-party applications. When you run a report in interactive mode, the DataBlock's dashboard launches in a restricted version of the Argos window client on the user's machine. Reports can use all 3 methods, whereas a schedule can only use the POST and GET methods. Although the Report API and Schedule API are configured in the same way, I will only show an example of the Report API during the training. For this example API, let's create an API report using the address information extract report, which was created during the Argos Report Writer training. Highlight the report and click on Edit. And this is the window for API. Notice that everything is grayed out. This means that the report does not have API enabled. To enable the API, click on the checkbox that says Make this report accessible to API. When activated, we have the report unique identifier, username and password to run the API, variables, values, and sample HTML code in the bottom. The report unique identifier is used by maps to identify the location of the report. If the report is copied or exported, then a new report unique identifier must be generated. The username and password are defined here. When an API is executed, maps will use these credentials to log into Argos. However, if you leave these blank, you will need to pass the username and password as parameters in the API call. And the variables section contains all the variables from the dashboard. And these variables can be set with default values. And we can generate sample HTML code for 3 different API calls: sample get, sample post, and sample interactive. When the sample button is clicked, Argos will copy sample HTML code on your clipboard. The same HTML code can generate HTTP or HTTPS, and you can control it via these 2 checkboxes. First, let's set the username and password. And now, anytime the API is called, Argos will use the administrator's credentials to log into Maps and run the API. And next, let's add values to the variables. The first value is for the entity type code. We'll use the %sign as a value for this code. Then we'll add values for the address type code. We'll add in the following: BI, BU, HQ, SB, EM, FA, and MA. And click on Apply to save the changes. And notice that each sample code can contain HTTP, HTTPS, or both. For this example, I'm only going to place a check on the HTTPS, since our map server is only accessible through HTTPS. This means that when I click on one of the buttons, it will copy sample HTML code on my clipboard with HTTPS. Let's quickly go over the get and post API methods before a demonstration is done. The get and post methods are automatic modes. This means the report tasks are generated without any user interaction within Argos itself. Required parameters must be either predefined or gathered by the calling application and passed to the API. This is done by use of the get or post requests. The get request is much like the standard URL web page link. The post request gathers any needed parameters in the calling web page. Using a get request, form data are appended within the URL. However, there is a limit to how much data can be placed. And for the first example, let's create an API call using the GET request. Click on the sample GET button. This will copy the HTML code to your clipboard as is noted in this message. And next, let's paste this into Notepad and save it to a location of your choice. Let's save this as API HTML. And now let's open it in a web browser. Notice that we have a link. When I click on the link, it will make an API call to Argos to generate our report. And here we have our extract report. If you attended the Argos Report Writer training, remember that we added a variable for the comments onto our report. We can pass parameters to the comment variable using the get method. At the end of the link, add an ampersand sign, the name of the variable, and the values you want to pass. For example, if I wanted to add a comment with the phrase, "This is a test," I would add the following to the API link. So the ampersand sign, the variable name, and the text. And now let's save and run this API. And let me just maximize this API window here. And notice that now in the comment area, we have the phrase, "This is a test." The next example is using the post method. Let's go back to the API in the report and click on the sample post button. Similar to the sample get button, it will prompt the user to set that the sample code has been copied to the clipboard. Now let's open up the API HTML file that has the API from the get method. And let's replace the code with the sample post. Now let's save this and open it up in a web browser. And notice that this time we have a button. When we click on the button, it will execute the API call to Argos to generate the report. We can also pass parameters similar to the get method, but it's handled differently. Underneath where it says all inputs here, we will need to add a new form object and the name of the object, and name that object the same name as the variable. For example, to add the comments variable, we need to add a new input underneath all inputs here. We're going to add the following. And that has the name of the comments variable. And let's save this and open up the HTML file. And notice that now we have an edit box for the comments variable. Any text that's written in the edit box will be passed as an argument for the comments variable. Let's put the same comment of "this is a test" and click on the button. Again, here is our report, and notice that we have a text, "this is a test," under the comments section. The last example I'm going to show is the API interactive method. Interactive mode allows you to call any Argos report or dashboard from portals, web pages, and third-party applications. Interactive mode can call any Argos report or dashboard in a restricted mode to the client computer. The users must be able to install software on the computer to use the report interactive mode. Users who use Mac PCs will not be able to execute an interactive API. Back at the API, let's click on the Sample Interactive button. And now that we have a sample HTML code in our clipboard, let's paste it in our API HTML file. And let's save this and open up the web page. And then let's click on the link. This will bring up the client, and we can select the parameters in the dashboard and execute the report. And here is my report. We also have the Argos Web Viewer API, which was introduced in MAPS version 4.3. The Web Viewer API gives us a way to embed Argos reports and dashboards into another web page, third-party application, or portal. For this training session, we won't be going over how to set up the Argos Web Viewer API. However, we do have documentation. This is called Accessing the Web Viewer API and is available in our documentation and software page. The last topic we're going to cover in our training today is the bursting task. When scheduling a report, the output file that is generated will be one single file. We can group our data, let's say by department, to organize it and make things easier to find. But we'll still get a single report that contains every department. Suppose you want to email this report out to each department manager. Each manager might not need or want the information from the other departments. So there's no need to send each of them the entire report. Bursting allows us to separate our report into individual files. Depending on the output format selected within the Process and Save task, each file could then be sent as a separate email, printed on a separate page, or saved as an individual file. Let's take a look at our address information data block. If we run the banded report, we can see that the output file is grouped by state. If we want to break this report out so that the information for each state is in a separate file and is emailed to the appropriate recipient, All we need to do is add a bursting task. First, let's select the schedule and edit it. On the Task tab, select bursting and add it to the added task list by clicking on the plus sign. In the bursting condition window, only the bursting condition field is required. Click on the ellipses to bring up the expression builder. And since you want to burst by state, we'll use the radio button to select our field from the database. So let's select state. For this example, each section of the report will be sent via email, so we'll have to add the send an email task. And if we want each section of the report to go out to different recipients, we'll have to make sure that the to field in the email task contains the email field associated with the bursting condition. If we hardcode the recipients, each recipient will receive every section of the report in multiple files. So assuming that there is an email address set up per state, we can go ahead and set the to field to the email address variable. So let's select email. And we can configure the from address, subject, and body. Now that you have set up our bursting condition, we'll need to make sure our tasks are in the proper order. We can use the up and down arrows to change the order of the tasks. We'll make the bursting task a second task by moving it under the Execute the Report task. Next, we'll make the process and save and send an email task, subtask of bursting. Now when the schedule is activated, it will separate the report into several individual reports per state and will email one report per recipient. Okay, and I do see a question, how does the system know what email address gets what state? So let's go back into the report. Actually, let's go back into the data block. Okay, and here we have our data. This is what is going to be brought back in the report. And if you take a look here, we have the state, and typically there should be an email address also associated here. So for the state of Georgia, whatever email address is included here, that's where the report will be sent. And just a reminder, if you run into any issues or have any questions, you may find additional information in our knowledge base. The knowledge base will help answer many common questions or issues. To use the knowledge base, go to the support page, support.evisions.com, and you can find a knowledge base here. Once you are on this page, you can find your topic either by scrolling down or using the search options. The topics are broken down by product and category. Let's do a quick search for bursting. And you will see the results of your search. We encourage you to look through the knowledge base as it may contain answers to some of your most common questions. And we have come to the end of the training. Thank you for attending, and everyone have a good day. Goodbye.